Hey guys, welcome back to Data Products. In this video, we're going to be doing a quick example vignette, as I like to say, on selectivity with graphs. So the last video we did selectivity with data sets to break them down by state, then county, etc. Now we're going to use a similar approach to break down how we display data. So let's jump right in. Okay, we'll start with a Shiny web app. Call this selective graphs. Clear all this stuff out. First thing, since we're graphing, ggplot2. Now let's make our UI fluid page, small page with only one capital. Select input. We're gonna say x variable, choices. We're going to go back to the iris data. If you've been coding along with me in all these videos, you remember iris. That's where we have like the sepal length and the sepal width and all these measurements from iris plants, flowers. So select input y variable, choices equals names, iris. So no having to download data for this one. Keep it simple. I actually tried. So I tried using the same data set that we used for the states, right? So like I wanted to do, we could compare smokers versus deaths in these counties. It was just too much data. The graph, it was just a jumbled mess, and it was not a good example. And so I started really getting into it, like, okay, let's make this look nice. And by the time the code was done, I essentially lost the plot. It's like, okay, I just want to show you this example, and it turned into this monster code. And I was like, all right, let's just use the iris data set. So you get the example, and we can move on. You don't have to build this Franken code that I built. But sometimes that's what happens. If you get into it, into R, you might get sucked into these rabbit holes because you'll actually find it fun. Okay, enough talking about that. So the last input, I'm going to say select input, geom, and then the input is going to allow us to change the type of plot. So it can be either, this should be point, not print. A point, a smooth graph, or a jitter graph, which you remember from our earlier data analysis or data products graphing sections. Okay, and then our plot output, we're gonna put our plot. Okay, so that's the UI. Our server, we're gonna say function input output session, and make the function go. We're gonna say plot geom reactive, so we want the plot of genome to react to a switch, or it's an input of geom. So we say switch the graph type if our geom input, that box, changes. So we're going to say point equals geom point, smooth equals geom smooth. So we just have to define what, and we're going to say standard error equals false. And then jitter equals geom jitter. Remember, that's where they just kind of space out the points, so you can see them better, so they're not on top of one another. Okay, and now we want an output plot, render plot, ggplot. So this is where we actually make the plot. So we say iris, our aesthetic is going to be our data input for X, data input for Y, and then add our geom, our plot geom. So that's, remember, our aesthetic layer that tells us what kind of plot to make it. And then let's make our resolution equals 96. and I got too much going on down here. It's closed off, so we should just need one curly bracket. All right, now we do shiny app and then UI server. Let's save it and hope it works. No typos. What? Why is it running? What's going on here? There we go. It's weird. It ran like my last videos thing. I don't know why I did that. It's crazy. Okay, so look at no typos. It's a first, which is good because I'm getting tired and I want to go to bed and not troubleshoot. So as you can see, kind of like our previous one. So previously we had it select literally and figuratively. So you could select the state, and then we had the command select input equals county or whatever in our last code in the last video. So this is similar, where, but they don't depend on one another. So previously, if you picked like Arizona, then only the counties for Arizona would show in the second variable. Here, we just want to be able to make all these comparisons, right? So we want pairwise correlation comparisons across both. So you can see that if we compare sepal length to sepal length, obviously it's a 1-to-1 correlation. But if we do sepal width to sepal length, you can see we don't really have a correlation, even though when we explore this data in our graphing, we know that it's actually, there are correlations, but it's when you divide it by the 3 species that it becomes, you can see the correlations. But yeah, you can make any of the correlations. So here are the species. So sepal width by species, you see that it kind of breaks. That's not a great one. You can see like the averages where they would be for the 3. So we'll do sepal length by width, and then you can change the graph type. So here's a smooth plot, and then here's the jitter plot, where if we compare jitter and point, you can see that instead of having these nice rows, we offset them by a little bit, so they're not on top of one another. So it makes it, you lose a little bit of accuracy in that you're moving things a little bit along the x-axis here, right? But you're also gaining a little clarity. So you're adding noise for the ability to see different points. Because if you have 2 points right on top of each other, you can't tell if it's 1 or 2 points, right? So that's what jitter does. So yeah, you can play around with it. These smooth. So pedal length to pedal width, that's a pretty strong correlation. That's pretty cool. So that is it. I'm done. No more vignettes. Like I said, we could go on forever with these things. There's a lot you can do in Chinese. There's a lot you can do in R. The only thing that limits you is your imagination. There's a lot of stuff that you can do. But hopefully, this collection of tools and little things that we've done, hopefully that gives you the stuff necessary to build your own Shiny app. I think it's, for a biologist or a data scientist, these are a pretty good solid foundation to being able to display interactive data, whether it's these graphs, and you can layer things, right? So in this one, we made it so you can select graphs. You could add the brushes, you could add all that type of changing the color, so you can make it so that you can pick out the color based on species. There's a lot that you can do and add these together to make a really cool interactive app. So that is it. If you are watching on YouTube, hit like, hit subscribe. We have no more of these. So I think this, for a lot of you, is going to be the end of the data products class. There is, if you're taking this on Praxis, there's going to be like a project, final project, and things like that. But drop in your comments if there is other things. I said this is the end. If there are other things that you're interested in that I didn't cover throughout this quarter, let me know and I can add more videos eventually. But I do want to get into Python for my next series of videos. There's a big demand from students in this class and people that have posted comments to do Python. So we'll probably jump into Python next and do introduction bioinformatics with Python. I'd like to do some maybe some machine learning or some computer vision and some things like that can be really useful for biologists. So thanks for watching. I hope you enjoyed the series, and subscribe to the channel if you're interested because with the Python stuff, because that'll be popping up in the next over the next couple months to be ready for my spring quarter to offer to my students. So thanks again, and I'll catch you in